Welcome to our GCSE Physics lecture on work done. Today, we'll explore the concept of work, its mathematical expression, units, and the conditions under which work is done. We'll also touch on the concepts of positive and negative work. In physics, work done refers to the amount of energy transferred when a force causes an object to move. Work is said to be done when a force applied to an object moves that object. The work done on an object can be expressed by the equation W equals F times D. Here, W represents the work done in joules, J. F is the force applied in newtons, N. D is the displacement in meters, M. The unit of work is the joule, J, where 1 joule is the work done by a force of 1 newton causing a displacement of 1 meter in the direction of the force. Conditions for work done. Work is done when a force is applied to an object. The object is displaced. The displacement is in the same direction as the force or has a component along the direction of the force. No work is done if the object doesn't move or if the movement is perpendicular to the force. Positive versus negative work. Work is considered positive when the force has a component in the same direction as the displacement. For example, pushing a box across the floor involves positive work. Work is negative when the force has a component in the opposite direction to the displacement, such as when friction slows down a moving object. Some examples of work done. Lifting an object against gravity. When you lift a book off the floor, you do work against the force of gravity. Pushing or pulling an object. Pushing a car or pulling a sled involves doing work to move the object. Stretching a spring. Work is done to stretch a spring or compress it. Now let's look at some of exam questions related to work done. Let's look at an exam question. Which situation involves no work being done and no energy is transferred? A. A car skidding to a stop on a road. B. A crane lifting a load. C. A heavy load hanging from a strong bar. D. A student dragging a big box over a rough floor. Try to figure correct answer. Work done involves the transfer of energy when a force moves an object. But there are situations where despite the presence of a force, no work is done. The correct answer is C, a heavy load hanging from a strong bar, where the forces are balanced and there is no movement, hence no work is done and no energy is transferred.
Question number 11. A builder lifts 30 bricks from the ground onto a platform 2.0 meter high. Each brick has a mass of 4.0 kilogram. What is the work done against gravity by the builder in lifting the bricks onto the platform? Option A 80 joule, B 120 joule, C 240 joule and D 2400 joule. So first of all, here we have to find out the work done. Work is the product of force and distance. Here force is not given, but we can find out this force by using F is equal to mg and distance is d, where mass is given, which is 4.0 multiplied by the value of g is 10 and distance is given, which is 2.0 meter. But it is given here that there are total 30 bricks and the mass of each brick is 4.0 kilogram. And we have to find out the work done by lifting all of these bricks. So the total mass will be the product of total bricks multiplied by the mass of each brick, which is 4.0. So here I also multiply with 30 so that the value of work will be equal to 2400 joule. Here option D is correct. Question number 9. A stone of mass m is held at rest in water. The stone is released and falls vertically a distance h. The stone reaches a speed v. Some of the original energy of the stone is transferred to the water. As it falls, resistive forces causes the temperature of the water and stone to increase. Which expression gives the work done against the resistive forces? So here we have to write the expression to find out the work done against resistive forces. As the body falls, it loses its gravitational potential energy. And loss in gravitational potential energy will be equal to gain in kinetic energy plus work done against the resistive forces. So I write here loss in gravitational potential energy will be equal to gain in kinetic energy plus work done against resistive forces. Loss in gravitational potential energy will be equal to mgh. It will be equal to half mv square plus work w. We have to find out work. So work will be equal to mgh minus half mv square. Now we see the option. In the option B, mgh minus half mv square is given. So B option is correct from here. Question number 10. A horizontal force pulls a box along a horizontal surface. The box gains 30 joule of kinetic energy and 10 joule of thermal energy is produced by the friction between the box and the surface. How much force is done by the force? So in this case, work will be equal to the sum of thermal energy plus kinetic energy. I write here work done will be equal to kinetic energy plus thermal energy. The value of kinetic energy is given 30 joule plus thermal energy is 10 joule. So that the work done will be equal to 40 joule. From here option D is correct.